Alright, in our last lesson we completed Unit 7, and now we're going to be getting into Unit 8. The first lesson is 8.1, an introduction to arrays and pointers, Part 1. So, in this lesson, you're going to learn what a pointer is, as well as some additional unique ways to understand memory. Now, this lesson is going to assume that all text is encoded as ASCII. Another assumption being made is that the unsigned short int is going to be 2 bytes in size. That's an assumption that we're making for this lesson. That's not always true, although that's beyond the scope of this lesson. For this lesson, we're going to assume that an unsigned short int is 2 bytes in size. Okay, so let's begin. In an earlier lesson, you learned that you can use the printf function to display text. So let's briefly look at an example of text. Now, if you remember, lowercase letters will always begin with 011, and then the next 5 bits will be the corresponding letter of the alphabet. So this would be A, this would be B, and so on. Now, to make this a little easier to understand, I'm going to write it out the way I normally write out bytes. And now, of course, once we get into the numbers, each byte is going to start with 0011 and then the value of the number. And finally, we're going to end it with a null character, which is all zeros. So this string of text inside of your computer actually looks like this stream of ones and zeros. And of course, the spaces and the colons are just there to make it easier to read. Inside your computer, it's just going to be and so on. It's just going to be a stream of ones and zeros without spaces. So this is A, this is B, C, D, 1, 2, 3, and finally the null character. Okay, so make sure that you understand this part right here. You should understand that this is how the memory will actually look for this string of text. Okay, so let's go on now. So we store text in memory by creating a train of ASCII characters, and then we end that train with a null character. This entire train of text is stored in memory exactly as I show. Every character immediately follows the character before it. The word that we use for this is string. So whenever we have a series of characters of text, that's called a string of text. So in this case, the string of text is ABC123. And like I explained before, if you put quotes around a string of text, then you are specifying that it is a null terminated string of text. Now, a string of text is one of the simplest forms of something called an array, which is what you're going to be learning about in this lesson. An array is a collection of data elements where each data element has the same data type. For example, in a string of text, you have a collection of data elements that are characters, and each data element is the same data type. And in this case, the data type is char for characters. So the string ABC123 is an array of characters. Arrays are incredibly useful in programming, and we will get into them in more detail later on. Arrays are also often a source of misunderstanding for beginners, so I want to cover a few important points. Remember from an earlier lesson that you never have to worry about the actual addresses in memory where a variable is stored, because this is done for you by the programming language. Also, remember that you can give plain English names to variables. So let's take a look at some example code. If I write unsigned short int total equals 5, what is total? It is both a way to refer to the address in memory where the value 5 is actually stored, and it is also a way to refer to the value itself. For example, if I write printf the total is %i, and I write, this is unsigned, and I write total, let's go ahead and put this into a formatted a little nicer just so it's easier to read. And if we run this, and you see here the total is 5. Now, total in this case, I'm using it to represent the actual value of 5. But you can also use total to refer to where in memory this 5 is being stored. So there are two ways total is used. One, the value itself, in this case 5, and two, the actual location in memory where the value 5 is stored. So keep that in mind. Anytime you create a variable, you're basically doing two things. You're defining a specific memory address where you're going to store the value, and you are giving that value a name so that later on you can use it in your program. So it is both a way to refer to the address in memory where the value is stored, and it is a way to refer to the value itself. Every variable has some address in memory. This address in memory is not the value of the variable, it's simply where in memory the variable is located. Now, when we create this variable called total, theoretically this variable could exist at any one of billions of possible addresses in memory. You have no idea which one, and you don't have to worry about it because, of course, the programming language takes care of it for you. All you know is that indeed, at some location in memory, you will find something that looks like this. So, at some location in memory, you will find a string of ones and zeros that looks like this, which is, of course, the value 5. You don't know where in memory, but you know that it's there somewhere. So notice that this is 2 bytes because we are assuming for the sake of this lesson that an unsigned short int is 2 bytes in size. Now, for the sake of this lesson, let's give your computer a massive downgrade in RAM. Instead of you having gigabytes of RAM, let's assume you only have 16 bytes of RAM. Now, if you have 16 bytes of RAM, it's very easy to show how it would look. Each location in RAM is going to have a memory address, which we're going to express in binary. And there you go. So that's all 15, or rather all 16. So in each of these memory addresses, you could theoretically store a variable. Now notice that each memory address, because we only have 16 bytes of RAM, each memory address is only 4 bits in size, because that gives us 16 possible addresses in memory. At each address in RAM, there's going to be a byte. Every address in RAM corresponds to a single byte. Now this is true in your computer with your gigabytes of RAM just as much as it is true in our example. So remember, at every memory address there is 1 byte, which is of course 8 bits. Now let's imagine, for the sake of this lesson, that the unsigned short int is only 1 byte in size instead of 2. So we're going to assume that an unsigned short int is 1 byte in size for the sake of this lesson. So let's examine the following code. If we write unsigned short int total equals 5, now your programming language is going to choose somewhere in RAM to put this. This is, as far as you are concerned, entirely arbitrary. You have no idea where in RAM this value of 5 is actually going to be placed. Let's imagine that the variable total gets placed into the memory address 8. That would be right here. Okay, so this is the memory address 8 because this is binary for 8. So this is where we're going to put our value. So that means that the programming language is going to choose a place in memory. In this case, it's going to choose memory address 8, and it's going to change this byte, and it's going to change it to our value. So it's going to become, and there you go. So now your programming language has to remember that the variable total is located at this specific location in memory. This is something your programming language will keep track of. You don't have to worry about it. So right here, that is where the variable total is stored. Now notice in your RAM, the word total, the name of the variable, is not placed anywhere. Rather, your programming language is going to remember that this memory address corresponds to the variable total. The only thing that is actually changed is the value at that location in memory. We can see, therefore, that the variable total refers to two different things. On the one hand, it refers to the memory address, where the value is stored, and on the other it refers to the value itself. Now, what is total? Total is a way to refer to the address in memory where the 5 is stored, and it is a way to refer to the 5 itself. This should make more sense to you now, and we will talk about this more in the next lesson. So one more time, I want to briefly go over the process of how your programming language does this. Let's assume again that you have a very small amount of memory, only 16 bytes, which let's assume looks like this. Now in reality, your RAM is not going to look like all zeros. It's going to be a lot of different ones and zeros all over the place. And what's going to happen is your programming language is going to change the byte that you tell it to correspond to the value you give it. And I'll explain that more later. But for right now, let's assume we write this. Unsigned short int total equals 5. So as soon as you write this, once you run the program, what's going to happen is your programming language is going to look at this. It's going to say, okay, this is a variable that's called total, and it's going to have a value of 5. Then your programming language is going to say, okay, I've got to put this somewhere in memory. It's going to choose somewhere in memory. You don't know where, but it's basically going to choose somewhere. And it's going to say, this is where total is stored. And then it is going to change the value at that location to be what you have set the variable to. Now later on in the program, if you were to write total equals, let's say 2, then what's going to happen is your programming language is going to look at your RAM, it's going to find where in RAM total is, it's going to remember the memory address, and then it is going to change that specific location to be what you now set it to. So there you go. If you have any questions or if any of this is unclear, feel free to ask your questions.